Hey guys, I'm going to go over computation test number 3 because you are going to have a summative on this next week and I want you to be very successful. I'm going over the entire thing, so take notes, write any questions you might have, and meet me in tutorials if you don't understand something. So on this first one, it's just a division problem. 1 and 75/100ths divided by 5/10ths. You need to make sure that 1 and 75/100ths is your dividend and your divisor is 5/10ths. Now we have a problem. Our divisor cannot be part of a number, so you need to make that a whole number by moving this decimal to the back. So that goes away. Whatever you do to the divisor, you must do to the dividend to keep it equivalent. So now our decimal's in the back and we move it straight up. So then you just divide as if it was 17.5 divided by 5. 5 goes into 17 3 times. That's going to be 15. You're left with 2. 5 goes into 25 5 times. That's on the other side of your decimal, and you are done. Most people did great on this one, so I'm not going to spend a whole long time on it. I'm going to double check that I don't have any kind of negative numbers. I don't, so my answer is just 3 5/10ths. Now, this next question was the one that so many different students did not do very well on. So what I'm going to do is I'm going to fold up my paper so that we can just look at this and you can see how I would show my work and my expectation of how you should show your work. So if we start in parentheses grouping. In the grouping, I have an exponent. So I'm going to go ahead and complete that. That exponent represents a 3 times 3, which is 9, not 6. I did see a couple of you put 6. Now I'm going to bring everything down. I have 8 times, and I still have 2 plus 9, close that parentheses, divided by 7. Well, I still need to finish up my grouping. So if I do that, I'm going to end up with 11. Bring everything down, stay nice and organized so we don't make a silly mistake. Now, I saw this on a bunch of your papers and you still got it wrong. So let's see what we were doing wrong. I even saw this on a bunch and still we were not getting the correct result. You need to remember that this is just like a decimal. So maybe just like a fraction. So this does represent the same thing that 88 divided by 7 would represent. And that is a division problem where 88 is the dividend and 7 is your divisor. Then you literally just divide it out. Now, so many of you guys are really into making a decimal. I don't want a decimal on this. It's not going to be a decimal answer, so that won't be accepted. 7 goes into 8 one time. That's 7. You're left with 18 when you bring that 8 down. 7 goes into 18 2 times. And then here's where you are all making a huge mistake. I'm going to end up with a remainder of 4. And the problem is there's not a problem at all. This means you're done. Your 4, your remainder, you used to say remainder 4. We don't do that anymore. Your 4 becomes the numerator of your answer. And then the original denominator or your divisor becomes your denominator. So really this is a very simple problem that a lot of you I feel are making way too hard. You take your remainder, you pop it up as your numerator, and then you take that original denominator or divisor and you pop it in and keep it the original denominator that it was. So that answer should have been 12 4/7. So let's get that written down. If it does say fraction answer, it needs to be given as a fraction. Okay, let's talk about this next one. This is where you look at this and you should immediately say, "Oh, I see an inequality. Check that coefficient. What do we see? Ooh, I see negativity. You better switch that sign for clarity." So in my answer, I'm going to go ahead and do that. I'm going to place a K. I'm going to switch the sign from K, where K is. This says K is greater than, so my answer better say K is less than because I have a negative coefficient. When I solve this, I'm going to divide both sides by a -3. That is why we switched that sign. If you didn't do that, then 1, you're probably going to have a positive answer, and 2, you didn't know to switch the sign. So we need to make sure we're doing that. These cancel now because I took the negative with me. And then 45 divided by a -3 is a -15. Lots of positives on this one. So we need to remember that when we have a positive divided by a negative, that is going to give us a negative answer. Let's take a look at the next one. Lots of really good things I saw in this one, but a few of you did miss it. So on number 4, we just need to remember that we are going to make this improper, and the way you do that is multiply the denominator and the whole number, and then just add that to 2. So you multiply, then add, and that would end up with 16 over 7. You keep that 7, the original denominator, just like we talked before, it stays your denominator. I saw some people with a 1 there as the denominator, and that definitely messes you up. Then we have a division sign. Well, we're going to use SIR here. Stay, inverse, reciprocal. So like we know, 6 is the same thing, or -6 is the same thing as -6 over 1. So now I'm going to keep this same, it's gonna stay. I'm going to inverse my division into multiplication, and then I'm going to reciprocal 6 over 1 to be 1/6. Now notice I'm not even worrying about my negatives right now. That's because what I see is I have a negative divided by a negative, and a negative divided by a negative is a positive, so this should be a positive answer, and I'm just gonna go ahead and tell myself that so I don't forget. Now at this point, I would actually just simplify right here because the 16 and the 6 can be divisible by 2, and you can only do this when you're doing multiplication. So I'm gonna divide 6 by 2, and I'm going to get 3. I'm gonna divide 16 by 2, and I'm going to get 8. Now there's nothing else simplifiable, so I'm going to simply multiply across, and 8 times 1 is 8, and 7 times 3 is 21. And that is not simplifiable at all, so because I always want to double check that, my answer is a positive 8 over 21. Moving on, you've seen a lot of this equivalency going on. So we have fractions to decimals to percents, and we want to be able to move very fluidly between all of them. Now, most people did great on this, so I'm just going to run through it super fast. I'm going to use hundreds method here. I want my denominator to be 100 because that gives me my decimal, and percent immediately. Well, I need to figure out what I'm going to multiply by. 20 times 5 is 100, and 13 times 5 is 65. And that gives you all of your answers. 65 leads me to 65 hundredths as a decimal, so that's 65 hundredths, tenths, hundredths. Now I have my decimal that represents this fraction, and then for my percent, a percent is out of 100. So if you have a denominator of 100, you can literally make the numerator into your percentage. Some things I saw were that people actually kept the decimal here and just added that percent sign. We want to make sure there's no decimal in front. And then one more, well, I'm going to show you on the next one how you can just move those decimals if you need to. So let's look at this next one. First of all, I showed you here how you could make a decimal if your denominator is 100, but this one's 1,000, and there's a lot going on here, so I'm not going to do that method. Instead, I'm going to go ahead and take the 375 thousandths, and we are going to multiply it by 100. When you want to make a percentage, you can always multiply by 100. Well, since we have a base 10 system, a cool thing is that's the same as just moving this decimal twice to the right. So if I move it once, that is equivalent to multiplying it by 10, and if I move it twice, that's equivalent to multiplying by 100. So this decimal goes away, and I literally end up with 37.5, 5/10, and then you can't forget your percent sign. If the percent sign's not there, it's just not right, because you're telling me a story by using that percent sign. Alrighty, let's simplify this fraction. So when you simplify a fraction that's like this, here's my suggestion. And it's read, write, simplify. So if you missed this one, make sure you write that. So you read it, it's 375 thousandths, tenths, hundredths, thousandths. So I need to literally write 375 thousandths. And I saw some people with that as your answer, but that is not simplified. So I think that the easiest thing you guys connect with is probably dividing this by 25. So I'm going to go ahead and divide that by 25. When I do that, I end up with 15/40ths, which is not yet fully simplified. So I can easily simplify that again by 5. And when I do 25, guys, I really think about like quarters and a dollar. If I had $3.75, how many quarters would I need? I would need 15. But back to this, that would give me 3/8, and that is simplified. I saw so many answers where the percentage was 38%. If it does not say to estimate it, then please do not. All right, let's go to these last two. They were two of the most missed questions. They are related and need to stay together and go together. So let's see about this first one. The ratio of girls to boys in a class is 18 to 12. So I immediately may think like, okay, 18 needs the label of girls and 12 needs the label of boys. Remember, ratios, proportions, everything's about labeling. And then what is the ratio? When we learned this, I asked you to underline the word ratio and circle the word 2. What is in front of 2 is your numerator. So in front of 2 is boys and behind 2 is total. So the real question is boys to total. Well, boys is 12, and then total actually need to add up 18 and 12 to get 30 total students. So there would be 12 boys at a total of 30 students. So that was a completely acceptable answer. 12 boys to 30 total students. Or, and I saw a lot of people write it 12 to 30, which is another completely acceptable way to write it. And then yes, a lot of students asked if you could simplify this, and the answer is yes. You could definitely simplify this. And let's see, what will we simplify this by? 6, right? So 6 goes into 12 twice. So for every 2 boys, there would be 5 total students. These are equivalent and either of them would have been accepted. Lastly, we are going to take the information here in green and use it down here. If there are 12 girls, how many boys would there be? So many of you put 18, but if you see here, shouldn't there be more girls if there's 12 boys? So you need to actually rewrite this as a proportion. What we do know, and this isn't about total anymore, this is girls and boys. How many boys? Well, if I know there are 18 girls, and there are 12 boys, well, now the question is, I don't want 18 girls anymore. I want there to be 12 girls. How many boys would there be? And this is actually a proportion that you would then solve. Now look here. Don't all of a sudden go to make your 12s ones. This is not multiplication, and we cannot simplify those. This is a proportion. So what I would do, if it were mine, is I would simplify this very simplifiable ratio. So if I divide this by 6, I end up with 3 girls for every 2 boys. I just reduced that or simplified that by 6. And then I'm going to use that 3 and make it go into this 12. So I know that 3 times 4 is 12, and I know that 2 times 4 is 8. So again, I'm scaling these up by 4. 2 times 4 is 8, so the answer would have been there are 8 boys. I hope this helped. Your next computation test will be a summative grade and goes over all of this, so please make sure you study.